Mm. Okay, so as we have always done, whenever it comes to therapy like this, we won't go straight into what we're supposed to do. I want to know from you guys what's the what's the problem, what's the challenge you're facing, or something. I know there's some few guys that actually caught the whole concept, but might be new to a lot of other people. So I'd love to hear from you guys. Mm, mm, mm,
Good evening. May I have something to say?
Yeah.
Yes. We've been having classes back to back, like since Tuesday, and we still have a class tomorrow. We have a class on Saturday, to one
No,
point.
there's no class tomorrow actually.
So there's no
The
class tomorrow.
no, no.
You
Tomorrow
went
is supposed to have problem with installation, and I'm like, I'm going to be free throughout the whole day. So the link will be up throughout the whole day. I'll be seated here throughout the whole day, and anybody can join at any point in time. I also have some few people that said they want to discuss career and whatever, so we could also do that the whole of tomorrow, but no class tomorrow.
okay, but there's class. We are going to be having a class on Saturday.
Yeah, it's supposed to be. I mean, if you guys, if you want to have the class on Saturday, okay.
Please, I don't want to have a class on Saturday. I don't want to have a
Why?
class on Saturday.
You were there. You were there when the decision was made, weren't you?
No, I was
You guys dropped this week's timetable. I left it for you guys, and everybody was so hyped, and they did it.
really. Oh, I
I
wasn't
wasn't the one.
because some of us are very busy.
Okay,
And when we
understood.
started, it was like twice a week.
That was the idea. That was actually the idea.
And then I feel that that's more efficient because like you don't have to jam pack a lot of things all together.
So this is what happened. This is what happened, and I understand why it happened. You guys can keep on dropping. I can see questions in the comments. Just keep on dropping it. When I'm done addressing, let's say if I would come to it. So what happened was it was twice a week, yeah, and then there were there were three guys that were super excited about the whole thing, and they asked one question in first of all, like two classes that held this week was not supposed to happen. It wasn't. I didn't even prepare for them, right? But they asked the question and they were like, they wanted a three-dimensional class. And then everybody felt pumped about it and said, oh, they want to see what it looks like. And I mean, let me not say everybody, most people felt pumped about it. And we created a poll and they're like, okay, yeah. So that's actually why there's a bit more classes this week, right? So again, one of those people still suggested on the group that we should move even faster. But I'm like, I'm very sure that this rate we are
Fine.
going is too fast for a lot of people. So I said, okay, yeah, we would have to slow down for the rest of it. If not, we're going to leave a lot of people.
Please
Yeah.
let's slow down. Please. I
Okay.
this
So
space too much
consider.
to keep
Uh,
up with. Thank you very
fine.
much.
Sure. Okay. So career talk. Yeah. So if you read the website, if you took your time to look at the website, you would realize that within these few months or within these few weeks, I am completely open for anything. When like my DM is open for both career talks, for application for masters, because like there's some people that are like, how did you get Erasmus Mundus? And I would have to. So I'm like, okay, these few weeks, there are people that registered for the training not because of robotics, but because they want to be able to review their master's application, have their CV looked at, have their resumes and their motivation letters. So yeah, I've been doing that for some people like behind the scene. I can't obviously I can't come to class and review someone's motivation letter. It's kind of a private thing. So yeah, on Friday, a couple of guys might join at different points in time to talk about the whole career thing. Yeah. I understood the math, but I wanted to get a conceptual understanding, a more intuitive understanding of the concept of like the why. Good. So that's one of the things I wanted to show you. I wanted to show you today. I mean, we could still do that if you guys are comfortable with it, but that's not additional knowledge, right? Because I won't you won't bother about the code behind it. But I wanted to show you how the matrix, the homogeneous transformation matrix, helps to solve the um the movement of the frames in real time. I have a nice piece of code for that. So you add a new frame, you would see the visual results. At the same time, you would see the matrix responsible for that result. It's easier to interpret, no problem. So that's something we are going to do today. Uh, busy care. So busy, some busy, some day jobless. I mean, I know some people actually are very like very busy. So that's why we have the recordings. The recordings is going to be up for as long as you guys want. Because there's a friend of mine that is supposed to be on this class, particularly, he's working and he's not even in Nigeria to start with. So he's also having time issues and things like that. My brain is in pain after his full 4 hours of understanding the geometric parts. So we got to matrix conversion and then brain shut down since last night. I don't know what is wrong anymore. So that's the problem with moving from one branch of mathematics to another. Mathematics, as they say, comes to you. I would assume you've been doing geometry for a long time. You are very conversant with it, and geometry now seems more natural to you. And now you're in a different language, which is matrix. So things look a little bit more off. What I normally do when I encounter a new form of maths is I try to go back to the basics of that maths and understand it. But I only do that if it's important, like it's super important, because having to understand the basics of every single mathematical concept can be very difficult, right? Because robotics has a lot of maths thrown in from different places, and it's so much to keep up. So you could also use this as an avenue to maybe understand a bit about matrix, right? The first problem that I think you would face is trying to believe that you can take two equations and turn it into one matrix, right? And I explained that to me, there is no common sense way of doing that. It's a case where you don't know how to prove that A is equal to B, but you know that you can prove B is equal to A. So if B is equal to A, then A should be equal to B. So I explained that severally. Moving from the geometry into the matrix form is a bit difficult, but when you understand that the matrix reverse back to the geometry is the same thing, you your brain feels more easy doing it. Um, Latifa raised a very important point because 2D after that 2D class, um, we held a poll and we said I wanted to find out if people didn't understand or they just haven't been given enough time to assimilate it, and over 70% like it's just a matter of time. It's not that they didn't understand. So yeah, yeah, I feel would have to cancel Saturday, but I know a lot of people that is going to come for me. A lot of people that will come for me. um all right, um that being said, let's go into something a bit more visual. All right, so hopefully to help you understand how the whole matrix things work. All right, trying to see. Uh, okay, so we're 22. Fair enough. We are looking at, for this couple of days, I've been um, right. So I have my screen up, and we can do a little recap actually. Can do a little recap. This is on the 2D. At least everybody understands that so far. Big city life. Mm. On this side. Okay, so this is just a recap. I'm supposed to send this slide. I did the slide after the class because the things I needed to put in the slide were talked about in the class, just like brief reminders. Sometimes you don't need to go over the whole video to get the idea. Probably if you see fragments of the class, it's a bit easier to follow. Okay, either ways, the equation guiding us, and we've moved from this whole normal equation, geometry kind of thinking into matrix. So um, this is where the first issue came up. I think for Tracy that said everything was correct until we decided to switch it into matrix. So this particular place just uses the understanding of how multiplications work in matrix. In your free time, you can probably look at how multiplications work, and if we have a matrix like this one above or this one below, they're the same thing. You'll find out that there should be a video to help you with that. There should be a video to help you with that. And that will be solving simultaneous equations with matrix. And the walls kept tumbling down to see the But if you close your eyes, okay, hopefully it helps you understand how it helps understand. I haven't watched it, but it should be a good video. help understands how normal equations can be transformed and solved as matrix. This is just by the way, just to help um just to help anybody that is having issue with the whole conversion from matrix to from equations into matrix. And the walls got tumbling down in the city. I also dropped on the group chat. Alright, so back to what we're doing. So as of this slide, where am I? Nice, homogeneous. I just want to skip to where we have the equation. Okay. At least we know what this equation is as of this matrix, dimension matrix. At least you know what it looks like. I'm just like bringing, not as if I want to explain it from scratch again though, because the other recording explains that. But I'm just like showing you guys, okay, this is where we left everything before we switch into the code. So yeah, it helps to understand how number equations can be transferred and so that. Yeah, you're not seeing the screen. Probably you should exit and enter again. Also, I think your own camera is on. I think probably if you turn off your camera, I think it would be lighter for your browser or for your phone. Okay. Let's move straight to the application that we have. Just a little application to help us understand. So can everybody see my screen? Is there a question? Is that yeah, what's up? Tracy?
Sorry, Bakel, I saw my name on the chat. I I think I lost network. I didn't really pay attention when
Oh,
you were talking about yes. So this
okay.
link is it for me? Sorry.
Yeah. So you earlier said
Okay.
that there is the whole you understand everything when it was in geometry and then when we switched into
Yeah.
matrix. Yeah,
Yeah.
so this video is just about switching from equations into
Okay.
matrix. Yeah,
Okay. Okay.
so you probably just check it
Thank
out
you.
after the group. Yeah,
Thank you.
sure. So okay. That being said, let's take our 2D. Right. What I'll do is before I explain the code, I would run it and let me make it a bit bigger. This is what we have. Hope everybody can see it, yeah. And Let me see what it looks like. Okay, we have something like this. I'm going to give you guys the code because I just realized the buttons are a bit tiny at the top. But up here at the center we have our frame. This is like our ground. This is O. And what I want to, the little experiment I want to do is I want to show you how we can add another link or another frame. Because I think somebody said if there are 20 this thing, we have to solve 20 times. Initially, I would have given that as a task, but that's a useless and hectic task. So
Let me ask.
we
Let
have
me ask the question. Don't do that to us.
I don't know how to call your name, but there's I don't remember what I remember what I remember what most times if I want to throw shit, I'll just anonymous. But
Don't do
this I
that
don't
to us.
really.
What do you mean give us as a thanks? Please.
It would have been a fun task. It would have been a fun task, believe me. So what I want to do now is if we want to define a new frame, remember we said in order to move, let's assume this is you, and let's say you want to move to your friend's location, you would have to specify translation, that's the distance you are moving or the direction you are moving, and then rotation. At least that's two things I made very clear. And for translation in 2D, you need to specify X and Y. So up here, although it's a bit small, I didn't consider that, and I'm not going to edit the code now. Up here, we have, or I have, I can put 0.5. Let's start with something that is easy to visualize. 0.5 by 0.5, right? And then let's say no rotation. That is keeping our angle at 0. So you know that if this is your 0, the next frame should appear at 0.5, 0.5, which is somewhere around here. So if I should click add frame, it adds the frame for me. But what I want you guys to also look at is if I move this GUI away, I want to still be able to keep the details. So let me just, you see that in our terminal behind, we are printing a matrix. That matrix has 0.5, 0.5, 1, 1, 0, 0. This matrix is what is responsible for the rotation. If you remember, this place that is 1, if you go back to the rotation matrix, is cos. This place that is 0 is sine. And cos 0 is 1, sine 0 is 0. I can choose to add another frame. This time, let's rotate it. So we can still do 0.5, 0.5, and let's rotate it by 30 so I can prove another point. If I add the frame, you realize that we have now somehow rotated by 30 degrees. But what is more important is look at the transformation matrix. It is now 1, 1, 0 minus 0.5, 0.5, 0.866. Because why is it 1, 1? You know, the first time we moved 0.5 and 0.5. The second time we moved 0.5 and 0.5. Meaning this last, or let's say this end effector, with respect to this our origin, has moved a total of 1 and 1. Again, I would love you guys to ignore 001 at the bottom. This 001 at the bottom does not really mean much for now. So this code will just help you visualize and see that at the end of the day, whenever I want to do things that has to do with frames, behind the scenes, these matrices are always there working. I can go to where the matrix are being defined. You see all these many code, all these are just terere. Is what runs the app, is what runs the button, but what actually does the maths at the end of the day is this guy is here. This, this. You can see cos, that's C we did, cos, minus sign, minus sign. That's like the main thing, because with each frame we add, we just multiply the previous transformation to the new transformation. We just keep on adding it, multiplying it like that. The details of other things in this command or in this code are things that you can look at. You can put in any form of LLM and ask, okay, what does this do? What does this do? All this TK, this is Tinker. And as a matter of fact, this is not basic Python, because Tinker is like what we used to draw GUIs. So that is a bit. You remember the last time we did was just matplotlib, right? But now I'm using matplotlib, but I'm using a GUI. That is this TK. But just leave that alone. So if I go back to our code, now let me choose something else. I can say 1, and then let me go down by -1. If you can visualize what will happen if we go down by -1, our frame should end up somewhere around this lower line. Eniola, are you lost? At this point, you would have to you have to like play with it yourself to like try and understand what's going on. And then we can rotate by 90 degrees for the next frame. We add another one. This is the thing. Am I lost? I don't think I exist anymore. Robotics. Mhm. Just to let you know, we're still in 2D. We can literally do the same thing for 3D. Like, this is the problem for 3D. And then I can do one. I can do one. I can rotate about Z. I can rotate 30 degrees about Z. And I can add the frame. Do I have the frame in 3-dimensional space? And then I can still do 1 I can rotate about, no, let's rotate like 60 degrees. Let's rotate it about Y. I can add. And we have 2 links for the robotic arm now in 3-dimensional space. But more importantly, these are the transformation matrices that are responsible for it at the bottom. Technology. Each time a matrix is drawn in real time, or any single place that draws matrix. You've used CAD before. CAD uses a lot of these matrices. I can rotate by 10 degrees. In this case, we're going by the z-axis. Then we have another inclusion. Yeah. So when you start doing all these computations, you start hitting Python. Well, anyways, you will have to play with this yourself actually, and probably watch the last video. But this is as complex as we're ever going to go. Yeah, I know you just need time. This is as complex as we're ever going to go with math. There's a common, I just remembered. There is a very common meme. It's not common. I mean, it's just nerds. Um, let me get it for you. Uh, I have that somewhere on my LinkedIn. I have that somewhere on my LinkedIn. Slide. Posts. I just remembered. I think I made that post in, like, was it November or December? Let's see if LinkedIn can dig it up for me. No, LinkedIn cannot dig it up for me. Let's see. Let's just mark passes. Okay. No, LinkedIn can't dig it up for me. Last slide with Matrices Roscon. Yeah, I can find it. I can find it. But it turned into a very popular meme, because before you do a lot of application, there's so much maths, and sometimes the maths can be very annoying. But now that I'm even showing you the application now looks the application without understanding the concept, or like the maths behind it, the application looks like amazing. It's like it's it sort of amuses you that, okay, yeah, you can actually specify this and that, and you just add the frame. Then you have that, and I can go down -1. I can no, I want to, yeah, let me show you. I can go -2. I can have this on 0, and then my arm goes backwards like this. So at this point, it's just time to process it. But I'm hell bent on looking for that meme. I'm actually hell bent on looking for that meme. I'm just a noisemaker. Anyways, if there are any questions, I've decided not to add any more knowledge to the already existing knowledge. But if there's any questions, if there's anything you want me to, like, clarify, I can. Talk, 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 talk. And it's going to be highly ineffective. It's going to be highly ineffective. See. I know I saw that in somewhere. That was 2004, October 2024. Yes. I was literally this is the exact Roscon. I'm actually on the site. I remember the Roscon. I remember the year, but I've forgotten the speaker. That's the speaker. And it was obstacle estimation. I promise this is the only slide with my promise is the only slide. With maths. Now let's see. I promise this is the only slide with maths. Alright, can you bring it up? Nope, you can't still bring it up. Either ways, on this particular presentation, obstacle black and red shirts. On this particular presentation, he was taking a course on obstacle detection. Right, these are like some things you can just come and watch if you like just enjoy robotics. I spent a lot of time just playing around with this. Okay, either ways. What's the name of the YouTube channel? It's not YouTube per se. Not YouTube. It's Roscon. Roscon happens every year. Roscon happens every year. And they have different sites where they host it. This particular year was in they hosted it there on that site. One of my issues with Roscon is some of the things are like so like niched. Like, let me show you what I mean by niched. So somebody is talking about executors in ROS, and I never even knew that that was a thing. Someone is talking about CAN device support. You have another guy coming all the way from Gazebo. So like it's extremely niched, right? You have the best at different sides, like different things that you're working on. So it's not like you come here to learn everything. You just come here to see what's obtainable and then learn a thing or two. This is about nav2 and docking. Autonomous docking package is a general solution for those of docking and arbitrary charging systems. That's really nice. I think this was added. This is used in like all these robotic autonomous navigation vehicles. But the thing is, okay, now look at this. Look at this particular presentation. This guy is talking about docking, right? He's talking about how to park a car, how to, it must not be a car actually, any form of robot where you can charge it. Say for example a Tesla. How will the Tesla be able to drive and park exactly where it's going to charge, right? And now they've made use of frames. If you can see this, can I make this bigger than this? Okay. If you look at this now, we have 1, 2, 3, 4. Like there are 4 different frames. I haven't really watched the whole thing, but from the picture that is shown here, we want to be able to tell where the location of the dock is. So one of the things we do, especially underwater, at least I know I've done that, is we have this QR it's like QR code, and then we have a camera to be able to scan that QR code. So once it locks in with the QR code, we know the position of the QR code, and then okay, we can assume that okay, the car has to be at this particular position in order to be able to charge. Like let's assume these are the docking frames and these are like the ports to charge whatever. So the idea now is if we can, from where we are, estimate our distance to the QR code that we have locked in with, then theoretically speaking, we can sort of calculate the exact position we have to be relative to the QR code, because the position of the charger to the QR code is fixed. That is not going to change. So if we know the position, and we do know the position from the charger to the QR code, all we need to solve is our position from the vehicle or our robot to the QR code and then relate it to the charger. This is like one of the coincidence like that's happened, because like to show you this stuff is not just used in just robotic arms. And then here we look at translation. If you look at external detection, it's based on external detection, it's based on translation and rotation. Again, all those particular things. Staging, X is for translation, Y or yaw is usually rotation, and this is like an offset. So the thing is, you are going to run into it, and there's a problem that happens if you don't really understand how these frames work. Now you come into autonomous navigation, and this is not even robotic arm to start with. This is like a very distant part of robotics. But like you come into it now, and you might be sitting here, you might just be saying, okay. But this guy knows it intricately, and he understands what he's saying. Hence, he's making his presentation at Roscon. And if you don't understand, you end up just using the whole thing as just like a script kiddie. But if something now has to be changed, like that, it's not like, how do I put it? It's not copy and paste. You would have to now understand how these things work. Not to mention, the docking system does not come already designed. You are the one that would design the docking system, so you also need to understand the frames and the axes and all of that. So this we just stumbled upon that. So that's an application. Mm, yeah, so there are a lot of things, there are a lot of fun things here. Sure. A lot of fun things here. Anyways, this is what made me this is what made me come here. I promise this is the only slide with maths. There are always slides with maths. It's inevitable. Like it's so inevitable. Um, all right, so I think I would add on the group that more time has been requested, and I will just leave you guys So I'll just leave you guys to it. If you guys need anything, just you can ask in the group, you can ask personally. Then I'll also drop the link to the I haven't pushed these changes yet. I think I'll push the changes, I'll write a proper documentation. Getting the code out. No, that's pretty bad even for my standards. Do I fetch first? Git pull, am I up to date? Okay. Great. Great. Git pull. Um, okay. Okay, good enough. Then I will therapy codes. Let's do therapy codes. Comments, some changes. Okay, I just realized you're not seeing that screen. Sure. Okay. All right, so basically there is nothing we are adding to what we already know. So I think we can call it a day. I'll just give people time, you guys time to go over the materials and like try and catch up, and let me know when you're all caught up.